All right, this screencast is on the nomenclature rules, or how do we name compounds. I will tell you that this one will be a little bit longer. It's worth listening to all of it and doing the self-talk that I'm going to model. This process is not an easy one, but if you follow the 5 questions that I'm going to give outline here, it should make your the whole naming scheme easier. I will tell you, you will have to memorize some things, and the sooner you believe me, the easier of a time you will have. All right, so I'm going to model the thought process that's going on in your head. This is a process, so if you start at the beginning of this process each time you're asked to name a compound, and you ask yourself these 5 questions, it'll make the whole thing easier. You will eventually not need to do the self-talk. You'll be able to look at the compound and name it quickly. All right, so what is nomenclature? Nomenclature is literally the naming. So naming system for ionic compounds, and we will also talk about naming for some molecular compounds. Remember, ionic is made up of ions, and molecular is not. All right, in an ionic compound, you're going to put the cation first, which is the positive part, followed by the anion, which is the negative part. So you can see aluminum is the positive part, and oxide is the negative part. The ratio of the ions is not given in the compound's name because it's understood based on the charges. Again, so if you know the charges, then you don't have to look them up. All right, so here's the first question. So the first question that you ask yourself when you are working on naming a compound. So the first question is, does this compound start with a hydrogen? So if you are looking at, for instance, CaCl2, and you'll go, all right, self, does CaCl2 start with a hydrogen? And we'd say no. Well, then we would go on to the next question in this scheme in order to name it. However, this question, if we had, for instance, we have HCl and we're trying to name it, we would say, does this compound start with an H? And we'd say, yes, it's an acid. All right, so there is a list of 9 acids that I will have you memorize. There's way more than 9 acids, but these are the 9 that you're going to see most frequently. You have HCl, which is hydrochloric, HBr, which is hydrobromic, HF is hydrofluoric, HI is hydroiodic, H2SO4 is, wow, we lost our 4. H2SO4 is sulfuric acid. H3PO4 is phosphoric acid. HC2H3O2 is acetic acid. H2CO3 is carbonic acid. And HNO3 is nitric acid. Make sure you add in those 4s and 3s because somehow the numbers got dropped in my transitions. All right, well, if your compound didn't start with a hydrogen, maybe as you work through the process, you can ask the next question. You say, all right, are there only 2 elements and are they both nonmetals? Well, in our case of CaCl2, we have 2 elements, but they're both not nonmetals. So remember, on the periodic table, if you're looking at the periodic table, you have a zigzag here. These are metals and these are nonmetals. So if your compound is made up of 2 nonmetals, then it is molecular. And these you will use prefixes. And these are when you use a prefix to tell how many of each of those elements are present. The rules are you can use any prefix for the second element, but you can only use mono on the first element. And you're always going to change the IDE ending. All right, the prefixes that you will have can be mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Your endings, again, become IDE because it's a negative charge. Okay? Little hint, tetra, what's the game that you can play where it's groups of 4 lines and you block them out? Some of the lines look like this. It's Tetris, okay? So Tetris is Russian for 4. All right, so let's try some examples. CO2, are they both nonmetals and are there only 2 elements? Well, there's carbon and oxygen. Excuse me. And so that's only 2 elements and they're both nonmetals. So how do you name CO2? CO2 is carbon dioxide. Most people know that one. All right, so let's look at CO. CO is carbon. There's one carbon here and one oxygen here. So it is not going to be carbon dioxide because we only have one oxygen. It is carbon monoxide. All right. Let's look at the PCl3. All right. Well, P is phosphorus and Cl is chlorine. So we have phosphorus and we need to name our 3. So phosphorus trichloride. Okay, and then the last one, we have 2 numbers here. So now we're going to use the name for the 2, which is dinitrogen tetraoxide. This one's a little tricky. Are there 3 or more elements in the compound? So you need to count how many capital letters. So if you have CaOH in parentheses 2, there are 3, 1, 2, 3 capital letters. So that's the 3 elements that would be involved here. If you have 3 or more capital letters, you have a polyatomic ion. Remember, that's a group of atoms combined together with an overall charge. What you'll need to do for a polyatomic ion is just use the name from the list. So you need to memorize these, as I've mentioned before. You then carry on through with the rest of the questions that are in this screencast to name the rest of the compound. There is an ionic bond in here, but there's also covalent. So you have the front half is named maybe with a different rule, and then in this case the OH is named with the polyatomic. Here again is the list of the polyatomic ions that you need to memorize. You have acetate, cyanide, chlorate, hydroxide, nitrate, nitrite, carbonate, chromate, sulfate, sulfite, phosphate, and ammonium. You need to memorize these. I haven't mentioned it enough, I don't think. You need to memorize them. The sooner you know them, the easier it'll be for you to recognize them in the formulas. All right, the 4th question is the hardest of the 5. It says, is there a transition metal INTL, PB, or SN in the compound? If there is, then you have more than one oxidation state, and you need to know use what is called the stock system. That's where you use the Roman numerals. Okay, so when you have to use one of these metals, you need to tell what the charge is by using the Roman numerals. So if you have Fe plus 2, it is iron 2, and if you have Fe plus 3, it's iron 3. So if it's any of the transition metals, INTL, PB, or SN, that is when you have to use the Roman numerals. So in the next slide, I'm going to show you how you work through that. All right, so the first step is whenever you have to use a Roman numeral, for instance, let's say we're doing CR0, if it's written correctly, it looks like this, CR2O3. So what you have to do is you have to look up the charge on the other element. The other element would be the part that's not in the middle of the periodic table or a metal in the middle of the transition metal. So you have to look up the charge on the other part. In this case, oxygen is -2. Then you need to do what it's saying here is we're going to multiply down, and that will get us our total negatives. And then we need to make the same number of positives, because remember, when we're writing an ionic formula, your negatives and positives will equal each other. And then the last step is to divide up, okay, because then you will be finding the charge for the overall, the Roman numeral for the metal, the transition metal, and that will become what you write as a Roman numeral. I'm going to show you an example on the next screen. All right, so if you were given V2O5 and you were asked to write the Roman numeral for it, V is in the middle of the periodic table and it is vanadium. We need to figure out what Roman numeral we're going to use with vanadium. So the first thing we have to do is we have to look up the charge on the other element. Well, the charge on O is -2, okay? The next step is it said to multiply down. So we are going to take our -2 times our 5, and we're going to get -10. When we have compounds, ionic compounds, we always have to have the same number of positives as negatives. So we're just going to change our -10 into +10. Now we are going to divide up. and we're going to take our positive 10 divided by the subscript on the vanadium, or whatever element we're working with. So we're going to take 10 divided by 2, and that will give me a positive 5 is my oxidation state for the vanadium. So my Roman numeral for 5 is V. Now, I would need to finish naming this compound, the oxygen part, but for the first part it would be vanadium 5 and then something else. All right, here are some examples for some more Roman numerals. Keep in mind, the rule of thumb is if you have a Roman numeral bigger than 5, I would question that. Okay, it's not always a good thing to have a bigger than 5 Roman numeral. So if we're looking at Fe in OH in parentheses 3, and we're trying to figure out its charge, we look up the charge on the OH, and that's -1, and we multiply down, and we get -3. We make that positive, and then we divide up. And in this case, we would have iron 3, and then the rest is hydroxide. All right, that's one example. If we then look at CuSO4, we're going to look up the charge on the SO4, and that's -2, and we're going to multiply down. Now be careful. Sulfate is SO4. SO4 has a -2 charge, so when you multiply down, you don't get 8. You get 2 times the 1, so it's -2. You make it +2, and then you divide up. So this one is copper 2 sulfate. Okay. Last one, consider pausing and seeing if you can figure out what the charge is on the CO2 SO3 and then playing it after a moment. So in this one, we look up the charge on sulfur, and it's -2. We multiply down, we get -6, make it +6, and then divide up. And cobalt will have a 3 Roman numeral. Now, we don't know how to name the rest of this one yet, so we're going to leave it blank. We are finally on the last rule. So what is left that you have not already named? These compounds will all be made of 2 ions, and these are the basic simple ones. So if it's a positive charge, you just have the regular name. If it's a negative charge, you just do the IDE ending. All right, so now you can do the self-talk and work your way through any compound in this list. So the first question is, does AlCl3 start with a hydrogen? No. Are there 2 elements, and are they both nonmetals? No. Are there 3 or more elements there? No. Is there a metal in the middle of the periodic table? Pb, Sn, Tl, all those. And the answer is no. So this one is just the regular names. So this one is aluminum chloride. Okay. All right, moving on to the next one. Is there hydrogen? Does it start with a hydrogen? No. Are there 2 elements, and are they both nonmetals? No. Are there 3 or more elements? Yes. So we have a polyatomic there. So that one is carbonate. And we need to figure out the rest of it. Is there a metal in the middle? Pb? Yep. So now we need a Roman numeral. If you were to work through this, you would get lead 4 carbonate. All right, moving on to the third example. Does CCl4 start with a hydrogen? No. Are there 2 elements, and are they both nonmetals? Yes. So this one is carbon tetrachloride. Okay, next example. Does this start with a hydrogen? Yes. So this is an acid. This is acetic acid. All right. Does this LICN start with a hydrogen? No. Are there 2 elements, and are they both nonmetals? No. Is there 3 or more elements? Yes. So part of that is the polyatomic. We have cyanide. All right, the rest of it we need to continue on. So Li, does it start, is it a metal in the middle, PBSN, TL, and the answer is no. So then it's just the regular name. So lithium. All right, last one. Does it start with a hydrogen? No. Are there two elements and are they both nonmetals? No. Are there three or more elements? Yes. This is phosphate. And does the Hg, is it a transitional metal? And the answer is yes. So we would have to do the math here again, where you look up the charge on the phosphate, multiply down, and divide up. And when you do that, you get mercury 2. Hopefully by now you've been able to work through these. As I've said and mentioned multiple times, the sooner that you memorize some of these formulas and names and these 5 questions, the easier a time you'll have.